Hey, Matt.
Hey, Mike.
Hey, let's do a podcast.
Let us do so.
All right. Welcome to everyone who is listening to this podcast entitled Hacking the Grepson. I am Mike. I am here with Matt.
That's me.
He was the one who just said that's me.
Mike's the one that pointed at me on this audio-only podcast.
They don't know whether I pointed or not. I could be making that up. So this is a podcast about programming and development and adjacent disciplines. That's what I'm going with for a while. And one of those programming disciplines is JavaScript. You may have heard of JavaScript. I don't know. Do we need to describe what JavaScript is, or can we just assume?
I mean, in like a one-sentence summary, it's the programming language that is most commonly used by web browsers to display things on the screen. It is also used for a bunch of other stuff behind the scenes, but that's what it's like for. It's the UI in web browsers.
RIP VBScript.
Yes.
It tried. It was there. It was competing with JavaScript for a short period of time, but it lost.
I'm not familiar with VBScript, but I have to wonder how much worse it was than JavaScript to lose to JavaScript, which I think is one of the worst languages ever.
You know, sometimes it's sort of like how VHS beat out Betamax. Like, I think Betamax was the technologically superior format, but it didn't win because reasons. JavaScript is kind of the VHS.
VHS hit the critical mass that it needed, so that people invested in and JavaScript's the same way.
It's not about being the best. It's about being good enough, long enough, in front of enough people with sway, and then it happens. Anyway, so we've been talking about game dev a lot lately. We thought we'd take a little detour into some other things going on in the technology programming space, because there's always lots of other stuff going on. And one thing that is going on is this article that was, this blog post that was made by someone named James Garbutt. Maybe it's Garbutt, but it's got two T's, so I'm going to go with Garbutt. He is a self-professed software engineer and open source guy, and he wrote this post called The 3 Pillars of JavaScript Bloat. And I thought it was pretty interesting, and so I thought we should talk about it.
It's definitely worth discussing.
Yeah. So I think mainly to the thing that this brings up when I read through it is the term backwards compatibility. And I remember the first time I heard about backwards compatibility was probably when I was a young Mike, and I was reading some, video game enthusiast magazine. And they were probably talking about like the Super Nintendo or the Sega Genesis or something like that, and talking about how probably there was no backwards compatibility with the previous model, which was the Nintendo Entertainment System or the Sega Master System. And what that meant was that if you bought this new system, you would not be able to play your old games on the new system because they were not backwards compatible.
And that was like,
it was a totally new.
I was going to say, and that was like hardware-wise, they weren't even backwards compatible. You couldn't physically fit the cartridge from an NES into an SNES.
Yeah.
Have the SNES work.
Right. I mean, all four systems used a cartridge system, which was basically a big plastic box with a little circuit board in it that you shoved into a bigger box, and then it read that and played your game. But they were different boxes with different circuit boards and different openings. And so hardware-wise, you couldn't put a Nintendo cartridge into a Super Nintendo or a Master System into a Genesis. But also, the hardware that was running it would not understand the code that was in your old games, even if you could, and it wouldn't be able to run it. That is not something that kept going forward. When we got to like the PlayStation era, I would say.
Yeah.
When
it was when we got to the CDs and DVD era that it started to become possible to have a common medium.
The PlayStation 1 and the PlayStation 2 both read CD-ROMs or disc, maybe DVD. One of them started doing DVD-ROMs of some sort. But you could put one Hardware-wise, it was the same, but and they started being able to be backwards compatible. So like a PS2 could play a PS1 game, I believe.
Yes.
I don't know.
And
It's been a
PS3
while.
with 2, I believe, was also true. Right, and that went along with like CDs and DVDs having DVD players are not backwards compatible to CD players necessarily, but they use a similar enough
Right.
technology where they would use like, oh well, we'll just have both lasers in there so people can use this old thing.
Right.
And that once you're
Yeah,
and then once you're locked into one and you got backwards compatibility forever, it's hard to get out.
Yeah, and I mean, like, consumer.
That's what I
it's
mean.
a plus. Yeah, it's good for the consumer, but it's not as good for the producer, the people who are making the systems and the games, because you do have to add either extra hardware or you have to add extra software to the operating system of the hardware that can essentially like emulate the older way that a game was written in order to load it into the newer system. So that was extra effort that is not always worth it. And this may seem like we're going off on a tangent, but honestly, this article is
We just had to tie it back
somewhat
into game dev, that's all.
yeah, that's what I was doing. But this article pinpoints similar things with code in JavaScript. And so it's talking about bloat. It's talking about bloat. So basically what that means is when you're running the runtime of JavaScript, and generally these days you're using Node. Node itself is the thing that is essentially interpreting your JavaScript code that you write so that it runs and does the thing you want it to do. But Node has been around for a while. I mean, I think we're up to version 26, maybe now.
I thought we were on
Something like
23,
that.
but I'm always lagging behind on it, so
I don't know. It's 20 something, but I mean, that's a lot of major versions for a software program. I think most software programs
24.
do not get into the 20s.
well,
Yeah,
the current
24.
LTS is LTS's long-term support is 24.
Yeah. 24. Okay. So that's the one that, like, if you want to start a new project, it's recommended to use 24 because that's going to give you the longest amount of support for that code that you're writing.
Without also trying to get like the latest, maybe not quite supported stuff in it. So you're like, all right, this is stable. Let's go.
Yeah, stable, exactly. So one of the pillars of JavaScript bloat, meaning that the actual Node runtime and all of the files that go with it when you install Node just keeps getting bigger and bigger and bigger and bigger over time, is partially for backwards compatibility. One of the first headlines here is support for very old engines. And I think the thing that it's talking about there is things that JavaScript or ECMAScript, which is the actual technical term of what JavaScript is.
Which is not Emacs script, despite what my brain wants it to be every
Have you read it as
single
Emacs
time.
script before?
I know it's not Emacs script, but every single time I see it, that's what it is. That's what it says. And I have to like change my brain. Like, no, that's not what it is.
Yeah, and you know, I was wondering. I always forget what ECMA even stands for, which is probably why they went with JavaScript, because Java
Wasn't
is a
Ekma
programming
the bad
language
guy
that-
on Stranger Things?
I don't know. I stopped watching after season 1, so
European Computer Manufacturers Association script.
got it. ECMAScript, right? And ECMAScript actually includes more than just JavaScript. It also includes JScript, which I never used, and ActionScript, which I believe was for Flash programming.
I remember ActionScript.
Yeah, that was popular. Did anybody use JScript?
I didn't even know JScript existed until you just said it. I have seen that term written down. I thought it was somebody just shortening JavaScript.
No, it is a legacy dialect of the ECMAScript that was used in Internet Explorer.
Oh,
So
we don't talk about Internet Explorer.
yeah, no. So it was proprietary, niche, and nobody uses it. But yeah, ECMAScript, otherwise known as JavaScript, as far as this podcast is concerned, you know, it has improved over time, and so it hasn't necessarily had all of the same functions that it did from version 1. If you're using, like, you know, an older version of ECMAScript, you may not have some of the things that certain programs are expecting you have. And so a lot of the stuff in Node is there as sort of like it fills in. I think polyfill is one of the terms.
They had two terms in
that
there, polyfill and ponyfill, neither of which I had heard
Ponyfill,
before. Well, I'd heard of polyfill
You never
in
heard
a
of
completely...
polyfill?
Polyfill I'd heard of in a completely different context. that had nothing to do with
Okay.
this. It was more of a math thing. Polyscript is
Oh.
polyfill is apparently just monkey
Interesting.
patching. I guess
Yes.
I guess it has a real name. Ponyfill does the job of polyfill, but does it by you importing things instead of you modifying the state of the overall environment.
Right. And sorry, because you mentioned JavaScript is used by web browsers generally, that's really where the polyfill comes in, is that the browser itself may not support the command that the newer version of Node or JavaScript that you're running uses. And so a polyfill is kind of in there to, like you said, monkey patch, or essentially like write a not a legit part of the source materials code, but it does the same function. So it allows you to use that thing that you otherwise wouldn't be able to use.
Yeah, with polyfill, you're effectively tricking the interpreter into using your version of something instead of the built-in one, which, from a security perspective, I don't love, but is done in many languages. I think it's worth pointing out before we dive much deeper into this that one of the reasons that this problem exists, this specific type of backwards compatibility problem we're talking about here, is because JavaScript is an interpreted language. It's not compiled to a binary, right? Mm-hmm. So it's so people are writing code and then trusting that the environment in which it will run can run their code, which means when you release a piece of software in JavaScript, you kind of have to have a bounds of like, I know it will work at least as low down as this, at least far back on ECMAScript as this, and I'm hoping that future versions will continue to support these features that I have in here as well. In most languages, a lot of the problems that they're discussing here go away because we just stop supporting old versions. But because specifically in the case of JavaScript and browsers, people are using old browsers. People are using, like, it has an old, like, you've got embedded systems like set-top boxes that will often have JavaScript environments in them so they can render things. And those take, the chipsets on those take a while to be able to update in a lot of cases, and a lot of money. And so they don't get updated. And so we have ancient versions of systems running around, and people still are trying to push out versions of their JavaScript app that will work everywhere.
Yeah. The author here says, for these unfortunate souls who are still running old engines, like you said, in an embedded system that hasn't been updated in 10 years, they need to re-implement everything themselves or be provided with these polyfills that we're talking about. And alternatively, what would be really nice is if they upgraded. But you can't assume that they will, and so it's like you have to you have to allow them to continue to run by adding in all this extra code in the source material so that they don't break.
Well, there's an alternative to that, which is just saying screw backwards compatibility. I'm not going to support this.
Right. Well, and like I said, with the earlier example of consoles, like, when they made the Super Nintendo, they're like, sorry, from this point on, the only thing that will work with the Super Nintendo are Super Nintendo games. I know you have 100 Nintendo games that you want to keep playing, but you're going to have to play them on your Nintendo. You cannot play them on this new system. And that, like you said, avoids all of this backwards compatibility, monkey patching, etc., polyfill business.
Now, if I look at a language like, say, Python, that's another interpreted language that has had aspects of some of the issues that they raise in this article, not to the extent, in my opinion. But one of the ways that they've solved that is, like, when we went to Python 3, some things stopped working. And, like, if you try to load a Python 2 program in Python 3, there's a good chance it won't work. Even for something as simple as, like, print statements, they started requiring print statements to be functions instead of just, like, literally print space string. Right? That was a change that happened at one point in time. But the decision was made, people need to update, rather than the decision being, well, we'll just support that forever. And this is a common problem in computer software development, right? I was going to say computer science. In software development, it's not a computer science problem. It's a software development problem of keeping that sort of backwards compatibility and making a decision of, like, okay, we're going to support this forever, and have this basically it's a form of technical debt where you just have this thing, this toad that's sitting in the middle of your code toad, if you will. Put that in the
Code
band names
toad.
channel. You have this thing sitting there, this ugly lump that you can't really do anything about because it's necessary for dealing with things that you still have chosen to support, or more likely that your manager has told you you are that you are choosing to support.
It's so bringing up the Python example, because thank you for getting to like the heart of this, of like how long do you support code for that is written a certain way? Like usually, when you want to phase out an old way that a language handles something, you would deprecate methods, which basically says like, hey, this
will
method
go away
in
soon.
in this version of the code, this method is now deprecated. Please use this other, newer, better version. And in the next version, it will not only be deprecated, it will be removed. So it will stop working. But it gives you sort of a bridge between it's working and fine to it's gone.
Yeah. And one of the things they mentioned in the article is sort of the reverse of that exists too in a lot of interpreted languages, at least both Python and JavaScript, which is futures. Right? You can import a future version of a feature. Like, okay, we're going to release this soon. It's not out there really. It's not in the core language, but it's going to be
Beta testing.
So you can kind of import
feature
from a futures package to get certain functionality today that will eventually be available just without having to import it. And then sometimes that becomes its own set of bloat. Because then, like, well, do I have to keep that package around? That's it. No, you change your code and get rid of the futures part at some point.
Yeah. It does come down to a lot of like, how easy is it to update this code? Yeah. And if it's a web app that everybody has, that's in a Git repo that you can just change, done. But if it's in an embedded system or, something that has to be put onto a piece of hardware, like the hardware has to be updated with this new version of the software, that's not going to happen as quickly. And so you're much more hesitant to make a change. And so I think bringing up Python versus JavaScript, yes, both interpreted languages. I think JavaScript is, it seems maybe a little extreme to say, more wildly popularly used than Python in terms of where it's installed.
There are,
but like,
I think there's more people that have JavaScript interpreters. I know that's not the actual term for it in JavaScript.
Because every browser is a JavaScript
every browser,
interpreter.
Almost every piece of software that we're running on our smartphones and on our computers these days have, like, the UI at least is JavaScript. Like all these programs have embedded JavaScript interpreters eventually. Like if you're using an Electron app, that's what that is. Hey, I'm running JavaScript in a local app. Like, okay.
Yeah. It's a web browser packaged.
Yeah. Just tiny little web browsers. And those get released. And that is a binary, right? That thing that is it doing the interpretation is a binary. So it got compiled once and exists, and you can't necessarily update it directly. And that's the problem, right? If you have a chipset that you've embedded this little mini browser in with whatever version of JavaScript you chose to have in there at the time, and that's stuck, well, normally that's not a problem because you're also just loading code that's local. But with JavaScript, what is often the case is that you've got this little mini browser, and then we're downloading JavaScript from the internet and then trying to interpret it. So now you've got, and that's where the problem comes in, right? Because now we, as the people writing software, are releasing software, and we're like, well, I need it to work on that set-top box that was last updated in 2012. And you're like, that's a problem.
Yeah, so you can only use so much of the language. You can't use the new fun stuff. You have to write like you're in 2012. It kind of reminds me of like trying to send an HTML email, which has been stuck 20 years ago forever, just because of a similar reason, because it has to work on so many different places that it's got to be written, with not of the cutting edge. And so thus you get this language that has all of this like extra code to protect this lineage, this legacy of applications that have been written 20 years ago that didn't have all of the built-in stuff that JavaScript or ECMAScript, whatever it now has. So I'm almost like asking you, Matt, here, because JavaScript is so popular and it is used everywhere, I feel like it kind of has the Windows problem, because Windows also has a long history of backwards compatibility. Like, you can probably still run like a Windows 95 compiled app in Windows 11, but that's only because they wrote the operating system with probably a similar amount of bloat to keep those things running, and they just never made a cutoff at each Windows release to say, nope, now only this stuff will run. Nope, now only this stuff will run. Whereas I believe Mac OS has been more of that. It's taken a stronger line in the sand in terms of like what it will run. And I know that there was that big change a few years ago where like 32-bit apps stopped working in Mac OS, and you had to upgrade to 64-bit. Like developers, oh my gosh, I got to change my app to 64-bit, otherwise it won't run on any new version of Mac, and I'm going to lose all these users.
Right, and that was true on Windows as well. But I think they chose. Microsoft was like, okay, but we're going to provide this like emulation level effectively for running 32-bit apps, and both of those are viable options. Right, one is, sorry guys, you can't run this old thing. And that's a good choice if you're willing to kind of alienate, a small portion of your user base to continue moving forward and have progress. But the Windows way is also reasonable, of saying, okay, yeah, you need to start using 64-bit apps because it's 64-bit architecture. But we're going to provide you this emulation layer effectively for free. I'm grossly oversimplifying all of this, of course.
Super easy.
Yeah. And it will run your app. The operating system isn't running this 32-bit app on the hardware. Like, it is running an emulator that is running your 32-bit app, basically. And that's sort of the same distinction I see between like Python and JavaScript and how they're handling this. JavaScript is taking the Windows approach of, oh God, we can't alienate any of our users. What if one of them is slightly upset and can't run, Facebook on their toaster from 2020? It's too old. I can't do this. That's terrible.
Yeah.
And Python's like, yeah, that's great. Stop. Don't do that. Why are you trying to do that? That's dumb. I like my software somewhat opinionated in these cases. Like, I don't think we should be supporting Internet Explorer 2. Right?
Yeah. Yeah. I think that's why this is a good post, and it opens up a really good discussion, because I don't think there is like an answer. It's nuanced. It depends on where the programming language is used, how it's used, who's using it. And also, like you said, there's kind of a line in the sand that you kind of have to make, but there's no real obvious choice which way. You'd pick one, and like you said, they both have kind of major negatives. If you go with the Python way, like, sorry, all your 2 stuff is not going to run in 3, then there's a lot of Python 2 applications that people were like, ugh, this sucks. I don't want to have to rewrite it to 3, blah, blah, blah.
But there's also tools that would just rewrite it for you, and then people were like, oh, it's not that bad, right? But
right. Well, and also in this day and age of AI,
that's
like,
exactly where I was
you could probably just have it rewrite it, and it's not that big of a deal. So basically,
go ahead.
Yeah, that seems to come to the conclusion that the issue with JavaScript trying to go the way of supporting everything forever is not necessarily the better way to go anymore. I mean, it was when it started, but now it doesn't make as much sense. And
I think the issue is where the problem is being solved. I think you can support old stuff as long as you want through emulation. Right? There's no reason not to be able to do that. But that's being able to backwards compatibly run an old piece of software. The problem is, I think that people want to run new software on old machines and not run. It's not that about running old software on new machines, which is an easy problem to solve. But if you want to run on the old ones, but I don't know why we're putting that onus on developers, because that. And I know it's not a compiled language, but that's a compiler problem. Like, that is a how I'm packaging up this thing problem. Great. I write your code. This is why I like TypeScript as opposed to JavaScript, because it's not really the code I'm writing as TypeScript isn't what's executing, right? It transpiles it to Java. I don't know if that's the right term. To JavaScript rather. It transpiles it to JavaScript and then runs that. And that to me is the right answer. Is okay, great. You're writing your code. This shouldn't be a problem that developers have to think about. Is the way I think about it. All this dependency management crap is an indicator of a smell, if you will, a code smell.
That's what I was thinking.
Of just like a bad overall way of approaching the problem. And like we should be approaching it from a different direction. AI is a great example of this, right? Okay, so I want my program to be able to go get JavaScript from the cloud and run it locally. And I want to be able to run, and I have an ancient version of the JavaScript interpreter on there, the JVM, right? Is it a JVM for JavaScript? Sounds right.
Isn't it a JIT
compiler? That's a just-in-time compiler, but I thought JVM was like, well, that's a Java virtual machine, but I thought JavaScript. I don't know. Anyway, you have a thing that runs JavaScript on your...
We're very smart.
On your machine. I don't know a lot about JavaScript other than it annoys me. But why not have it connect instead of directly downloading a JavaScript file or files, a bundle? Why not have it go to a website that then looks at what you have as a capability and gives you back the JavaScript that will run on that machine, right? I write my code once in a way that's not horrible and bloated. And then if it needs to be horrible and bloated to run on your machine, okay. That's not my problem. That is then the delivery system's problem. Or someone just needs to write an emulator that can work on those machines, that knows how to interpret all your new JavaScript and turn it into old stuff. Just like that. Just a simple layer there. And like there's solutions to this, but we don't do them because it involves that extra step. But it's such a... We're distributing the problem to every individual developer rather than solving it more centrally.
Yes, and they actually mentioned this in the article. They say these layers of niche compatibility somehow made their way into the quote-unquote hot path of everyday packages. The tiny group of people who actually need this stuff should be the ones seeking out special packages for it. Instead, it is reversed, and in bold, we all pay the cost. So yeah, it's like everybody gets all of the niche edge case stuff so that no one is left out and nothing could potentially break. But that means everybody gets the bloated runtime environment. Whereas I really like that idea of like there should be an extra step where it somehow knows, it reads your code and knows the things you need and then gives you only the code you need to run that and not everything.
Yeah.
But yeah.
But also a lot of that has to do with how these packages are bundled, right? The assumption is kind of like baked into how JavaScript works, at least my understanding of it. I could be wrong about this. I am not a JavaScript expert. Is that like, okay, everything I depend on is coming along in this bundle so that it all kind of works self-sufficiently. And that's why that's so big. Every single thing that I depend on is getting bundled together in this one little place. Instead of saying like, hey, here's the things I need to depend on. And I stop there and then let the rest of the system, the back end of the system, provide that. And if you added that sort of abstraction layer, I guess, in there as sort of the default way of managing it. And I know that a lot, like I mentioned Electron as a type of app. And like, I know for the most part, that is kind of what that does. Is it provides a little bit more of that. But it's ultimately, it boils down to the bundling and how we do that is where the bloat itself actually is. And if we didn't bundle things the way we do, and we made different assumptions, it could be broken up much more simply.
Yeah. Another thing that they brought up is this atomic architecture of JavaScript.
Yeah.
Where like lots of very small bits of code get their own package. And so lots of your dependencies then, depend on those. And you get this graph where there's a lot of duplication or like a package that is used by one other package. It's like someone will make a package, but then they'll split it into three packages that only refer to each other. And then when you make an app and you pull in dependencies, you just get a lot of duplicated dependencies because lots of things rely on the same little atomic things, which means you have the same bit of code duplicated over and over again because so many of your dependencies depend on the same things. And also we run into that thing, which reminds me of the left pad issue that happened years ago, where somebody like the maintainer of that package, I believe, took it down for some reason. And so all of these people's apps that depend on that one little bit of code that is like a package of like, 2 or 3 lines or something doesn't work. And so when you distribute it, it's good because it's easy. Like anybody can get all the dependencies no matter where they are, as long as we have this internet of packages. But it also means that someone can do that. They can go to the thing they maintain that millions of apps require and take it all away, which is maybe adjacent to this issue, but it's still part of the architecture of JavaScript itself that kind of lends to this kind of thing.
Yep.
Yeah. And then the other one they mentioned was the pony fill, which is different from the polyfill, and it kind of is adjacent to or related to your futures idea of like developers wanting to be able to use something that is not yet part of the system, and so they import this package. But then when it does come into when it does become part of the regular distribution of JavaScript, the pony fills don't necessarily go away, and people are still importing them. And so it just further bloats the package that, the space that you could be downloading. And yeah, now, once again, I feel like all of this kind of goes back to like, it's an interpreted language, it's distributed, it's not something that's compiled at the end, so it doesn't necessarily do any kind of like, maintaining or what's the thing where you go to a garden and you
Weed
sorry, what?
Weeding?
Yeah, it's just that thing where, the code, the package that I'm deploying is 30% of it is code that I'm not even using. Yeah. Just get rid of that, as opposed to it just being there because it's a part of everybody's package. Exactly.
That's a problem that exists all over the place, I think, in coding, not just JavaScript. And it kind of goes back to that technical debt issue. We don't do a good job of revisiting our programs to keep them agile and light and like functional. It's just like, great, keep shoving stuff at this to patch the problem instead of going back and doing like a big refactor or reconsideration. And a lot of the suggestions this guy has did go back to the developers, like our side of like, hey, maybe go through and see if you have a lot of overlap and what you can do about it.
Yeah, I mean, I don't think that there's no responsibility of the developer to think about this. But, I think most people who develop in JavaScript, who make stuff for the web that has any kind of interactivity, thus JavaScript, has a node modules package full of dependencies. Yep. 99.9% of it, you don't know what it is. You don't know what it does. You don't look at it, you forget about it. It's just like, hey, I want to make a React app. I want to make a Vue app because I like how React works, or I like how Vue works, or how Angular works, or whatever, or Ember. And the dependencies that framework needs are just like, okay, whatever. It needs that so that when I go to my webpage, it runs. But in terms of like, does it need all that stuff for my app? I think, the hard drive space, internet speed, computer CPUs, everything has just gotten so good to a point where we can be this lazy and dismissive. Yeah. And so that's where the bloat just happens naturally, because nobody is really thinking about being agile and tight with their dependencies, because we're not running on ancient computers with 1 megabyte of hard drive space and everyone's using dial-up.
64K of RAM.
Yeah, like back then, you were probably writing in C or something similar, and you had to think about memory allocation and garbage collection, and now you don't. And so, sure, whatever. I don't know. It's got 900 megs of dependencies, but does my web page come up and work? Yeah, so it's like incentives are misaligned because technology has made us kind of lazy.
Yeah. Yeah. And I think that's a good thing that it makes us lazy, because it's things that shouldn't be worried about by the developer. This is the job of the interpreter and the compiler, in my mind, is specifically to abstract this way. It's why I prefer coding in Python to C. I know how to code in both, but I have to deal with a lot more crap. You mentioned memory management and all that other stuff, garbage collection type things. I don't want to think about that. That is not an important aspect of my code trying to accomplish its task. It is necessary, but it's not something that the developer should have to work. Same with like, same reason I don't transpile all of my code directly into binary myself. Like you push these things off onto the proper tools and simplify everybody's life.
Yeah. But do you feel like, is there really anything that you plan to do as a programmer to ameliorate a system like this? Or is this just kind of the cost of doing business with a popular web language at this point?
I think there are plenty of people out there who rely on JavaScript who do have that sort of like middle layer, that sort of middleware that deals with a lot of this stuff so that the developers don't have to. Right? If you have a layer that you can rely on that definitely has this stuff, then you can write all of your code so that it works with that stuff, right? If it's a limited subset, you can, and this is also where I like generated code, right? Because functionally all code is generated code at this point. You write the code and it's interpreted into machine code. That's generated code, right? Even compiling is that. To
You
some
didn't
extent.
write the machine code. Yeah.
Right. I just like to take it up a level and generate.
Yeah.
So like for me personally, that's how I deal with problems like this. If I have to deal with, I only want to write this code once, but it needs to work on old systems. I rely on things like the TypeScript compiler for that. And I think that's the right answer. But a lot of it really boils down to the needs of the specific system that you're writing. Right? I can't change how JavaScript works fundamentally for everybody. So I can only deal with how it works for myself. And so I know there's tons and tons, I'm sure, of different ways people have hacked around this problem out there in the industry. And it's just a matter of someone who has the influence and power of consolidating all of this into a meaningful way of moving forward, and also being willing to just say, sorry, guys, we are no longer going to support this original feature that is causing so much headache. If you want to do this anymore, write your own package. Bye.
Right, but that means that the ATM at my local bank might stop working.
Or they could just update their hardware.
But it costs, $50,000 to update the hardware, so they're never going to do that.
Right, but how much is it costing to keep the software, hiring all the software people to do it, right? It's a question of like one-time costs versus ongoing costs.
Yeah. I mean, yeah, there is a line that must be drawn, but it also the middle fuzzy part where you are like obviously there's stuff that's so old that no one expects to work anymore. And then there's the middle ground where we're kind of like making room for the stuff that isn't cutting edge, that is, a few generations old. And then there's like the future cutting edge stuff that, and those two ends are niche. And then most people are in the middle. And like at some point things stop working and you either have to upgrade them or write something new. And that's kind of just, I'm kind of saying this out loud to get confirmation from you that like that's just how technology works. That
That's
no
how life
technology, nothing ever created is believed to work forever. At some point, it will stop working, and you need to try something new. That's kind of the crux of it.
You see this in real life, right? I can take this completely away from software engineering and just with any sort of advancement in technology. There's always somebody that's going to want to stay back, whatever reason, right? Going from coal to solar, right? Power. Well, you've got people that are working in the coal mines and they need money and they need to have their jobs so that they can live. They don't want the advancement, right? And as a system, in this case, it would be like the civilization or the society, I guess. We could be like, hey, that's cool. We're going to pay you to not do the coal stuff anymore and train you over to do the solar, right? Which would be the equivalent of saying, okay, this is deprecated now. We're going to move over to here.
Right.
Coal will no longer be used in 10 years.
Yeah.
Get ready. Or you say, well, that's a problem. I don't want to deal with it. So we better make sure we keep coal around forever. Right. And that's just like an example of it. But the same idea pops up throughout life, not just in software and not just in technology. People want things to remain the same because it's what they know, it's what they're comfortable with.
Yeah. But also, we're always advancing and progressing and trying to make things better and faster and easier. And as long as that is, as long as that is the directive, this is a problem that will constantly come up, and there will be different ways of handling it and pros and cons of each. And yay, we've completely generalized this specific blog post about a specific technical issue into a bland catch-all statement about existence. Woo, we did it.
Everything's trade-offs, baby.
Everything is trade-offs and risk management. All right, you heard it here first at Hacking the Grepson podcast. We have explained everything. Thank you to James Garbutt. I'm sorry if I'm butchering your name, but it's got... Oh, yeah, maybe he's French. I don't know. For the 3 pillars of JavaScript: bloat, backwards compatibility, atomic architecture, and these darn pony fills, which just makes me think of My Little Pony. I'm sure whoever coined it was a fan, because I don't know how else you come up with that.
I assume it was just, okay, it's not a polyfill, it's a ponyfill. I'm sure it was just that.
It could have been a pokefill, just saying. But I just wanted to end this with one of the author's closing thoughts, is that, he, like you said, there is a community effort of this thing called E18E and NPMX and such that help with documentation and tooling, but there's also the developer take a look inside yourself and your dependencies and ask why, and raise issues with your dependencies, asking them as if they were something that you could talk to and would talk back, and why they need these packages anymore. So there's definitely a hey, if we each individually think about our apps and making them better, we can fix it, quote unquote, is what they say. So I there's a part for us to do, but also, I don't know. I'm often very fatalistic about this stuff and think that, it's just going to happen again. So, use a measured effort. Don't devote your life to making JavaScript less bloated, but, do a little bit here and there.
Did this person invent the name Ponyfill? Because when I just searched for why is it called that, it linked me back to this article.
I doubt it, because they talk about it.
They talk about the whole, it's like polyfill, but it's a play on polyfill, but about unicorns and sparkles. That's popular. I'm like, what are you talking about? I found an article. Well, I found an older article that talks about it. So it's not just this.
Yeah, I mean, the polyfill apparently came from Remy Sharp, who is, I remember reading Remy Sharp's web blog posts about development back in the day. He's kind of a legend. So I didn't realize he also came up with that name. That's fine. But if you did web dev for as long as I have, you've heard of Remy Sharp. Also, it's just a cool name. It almost sounds cool. Made up. Okay, so I think that's enough for this article. Thank you for the article and the inspiration of the discussion. There's a lot to be said about this, and I think we've said enough for now. We invite you to listen to all of our other podcasts at hackingthegrepson.com. We continue to put out an episode every other week on Wednesday. And until we talk at you again, we now return you to your regularly scheduled lives already in progress.